Hey guys, I'm Jade. Today is my LeetCode review vlog on the 141st problem, linked list cycle. We are given a height, the height of our linked list. We have to determine if the linked list has a cycle in it. And there's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that next pointer is connected to. We have to note that position is not passed as a parameter. We have to return true if there is a cycle in the linked list. Otherwise, we have to return false. Let's see example 1 here. We got 3, 2, 0, -4, and the position 1, and output is true because there's a cycle in the linked list where the tail connects to the first node. And for the example 3 here, we got only one node, and the output is false because there's no cycle in the linked list. Then, let's get started with our intuition to solve the problem. So, we have to detect the cycle, and the main challenge is we have to identify a repeating sequence without using extra space to store nodes already seen. And there are two popular approaches we can achieve this. The first is a hash set. We can traverse the list and store each node in a hash set. If a node reappears, then which means a cycle is detected. So we'll return true as we detect a cycle. And there's also another better solution called Floyd's cycle detection algorithm. Oops, I tapped E more. And the detail is we can use two pointers move with different speed. The slow one would move one step at a time, and the fast pointer would move 2 steps each time. And if there's a cycle, the fast pointer would finally meet the slow pointer. Or if the fast pointer reached the end, which means there's no cycle. Then, let's get started with the code to solve the problem with the Floyd's cycle detection algorithm. So the very first step, we have to handle the edge cases, which is if height is equal to null, we just return false. And the second step, we have to create two variables to help us solve the problem. For the first variable, let's call it list node. Let's call it slow pointer, and start it at height. Then we have to create a fast pointer started at height dot next. And the slow pointer would move 1 step at a time, and the fast pointer would move 2 steps at a time. And there's one thing we have to remember. The two pointers started at different positions. This is because we have to check if slow pointer is not equal to the fast pointer in the following code. Because when they are not equal, we have to continue the while loop. And the next step is we can have a while loop to check if slow is not equal to fast. If so, inside the while loop, the first step we have to check if the fast pointer reaches the end. If fast pointer equals null or fast pointer dot next equals null. In these two cases, which means the fast pointer reached the end, so there is no cycle, we just return false. And on the other hand, if fast pointer doesn't reach the end, we have to update the slow pointer and fast pointer. So we have to move slow pointer 1 step ahead, which is slow equals slow dot next. And we also have to move fast pointer 2 2 steps ahead, which is fast dot next dot next. And out of the while loop, which means the slow pointer equals the fast pointer. And the further conclusion we can get is we found a cycle as the slow and fast pointer meet each other. So we just return true. Then let's check the correctness and analyze our time and space complexity. So the time complexity, it is big O of n. And n stands for the number of nodes in the node list. Yes, our code got accepted. Our time complexity, it is big O of n. And if a cycle exists, it will be detected faster. So the overall time complexity, it is big O of n. And the space complexity, it is big O of 1. Because we only create 2 pointers to help us to find the cycle. And there is no more space we use which is related to the input size. And this is the end of my LeetCode review vlog on the linked list cycle problem. And I highly recommend you guys to visit my online GitHub page here. You can see all the nodes for the top 150 LeetCode problem. You can see the problem description, intuition, main idea, and different solutions with Java code and annotations, and the final time and space complexity analysis. And you can also visit my GitHub repository here, which contains the codes and nodes to build the online GitHub page. And this is the end of my LeetCode review vlog, and I'll put those 2 links on my YouTube description below. And thank you guys for watching. See you next time.